False position method is a method for solving nonlinear functions just like the bisection method. It is one of the iterative methods of finding the roots of a nonlinear equation of the form f, x, equals 0. Firstly, we have to define the interval or the region of interest. If f, a times f, b, less than 0, then we know that our function must cross the x-axis at least once. Then, we have to find c.
So, how to calculate the root? First, we have to determine the interval. It can be any value as long as the value of fa times fb is less than 0. Here, I choose xa equals to 1 and xb equals to 10, which each value of fa times fb is less than 0. Now we can move on to the first iteration. We have to find the value of c by this formula. Then, find fc. As you can see, fa times fc is less than 0. For the next iteration, we will use the c value as the new b value where a value is fixed. The process is repeated until the root is found at desired accuracy or fc is equals to 0.
First of all, we will be typing in all the required commands or the programs that we are going to use. So as such, as we can see below, I have programmed the commands of sum, whereby we will input each of the coefficient times the a power of 4, 3, 2, 1 and so on. Okay, so this sum formula is useful since if we were to change the coefficients on top, it will follow that change and it will change straight away in the function as well. So we don't have to retype the function given. And then we will just copy paste into the respective places. And then we have to determine whether or not the root lies in a given interval or not. So we will be using the if or statement. And also for the next lower boundary, we have to determine using if statement, whereby if fa times fc is less than 0, then we will remain the value of a, or not, we will use the value of the x or the trial roots. Okay, and then afterwards we just copy paste all the given or written commands into the next few rows, and then we will get the smallest error as our closest root to the actual root. So you will actually get the same answer as in your actual calculator. And then in the end, you will be using a graphical method to really determine whether or not our given interval is correct or wrong. Because sometimes an interval will provide you with two roots, which will not work in this case since false position method only works for one root at one given interval at a time. So as you can see there, I have changed all the coefficients of certain x values, and the whole data will change together with it as well as the graph. So this is actually like an actual calculator which follows the coefficient given.